My name is Gerald Mace, and this is my ENME 351 final project where I make a desk fan that oscillates and has speed control. The hardware consists of a L298 motor driver connected to a 9-volt battery, which helps simplify the motor control. A DC motor which is connected to the motor driver. This is what is pushing the air. Below that DC motor is the servo, which is helping the fan oscillate back and forth. There is a potentiometer which helps control the fan speed, and lastly, all of these components are connected to the Arduino, which is doing the processing. What gives it its charm is the construction is just entirely cardboard, and it's all held together with hot glue, and the rotor itself is just made with bottle caps, just things that I had around the house. These next two clips, I'm showing how you change the speed. Essentially, by playing with the potentiometer, you are changing the analog signal, which is read by the Arduino. It turns that into a pulse width modulated signal via the code, sends it to the motor driver, and that is what changes the speed. The Arduino portion of the code consists of doing an analog read and entering different if loops based on a variable that changes the angle of the servo. But it's always reading what the analog signal is and then printing that out as the duty cycle for the DC motor. The processing portion of the code is reading what you see here on the serial monitor and through some quick equations turning those into dimensions to display not only the power that's being sent to the DC motor but also the angle of the servo at any given time. So as you'll see in the next clip, the fan power is dependent on the voltage that the analog read is picking up on the potentiometer circuit, while the angle is just dependent on time. Some possible improvements to the construction and the hardware would, number one, possibly getting a motor rated at a higher RPM to get a much higher output in airflow, and possibly powering the server off of an external output due to it not being rated for the voltage that the Arduino is supplying. This has been my presentation for a design that senses voltage, actuates motors, and displays information via processing. Thank you very much.